And hello.
Hello.
Hey, so David, you're in Barbados.
Hey, yep.
It's 2 o'clock there.
It is. And sunny. Rubbing it in.
Awesome. Wow. Yeah, so for those that don't remember, this is the long-awaited part 2. Part 1 was November, I believe, 24. It was around November. And we started digging into this big deck that you had on like ASP.NET Core architecture and some of the design decisions and stuff. And kind of like we went kind of deep into some specific things like why DI is set up how it is, and talking about like some of the composition. And so our plan for this one, I believe, David, is we're going to kind of go more through the deck, and we'll take questions as we go, and it'll be kind of like we'll focus on that. Sound good?
Yep.
Let's start, as we always do, with some community fun. So here we go. The community links, I'm pasting them over in the chats, and let's just go for it. So Anthonyreddy he's just constantly cranking out all this cool stuff on web services, connected services, all sorts of stuff. He's been doing some things on testing gRPC lately. So this is one of his posts that he did on using gRPC curl. And this is a walkthrough on using the tool. So installing it, it's a Go-based tool. So he shows how to install that using Go Package Manager, and then just how to call gRPC or grp curl. I guess we don't repeat the C there. So just a walkthrough on how you can debug and test against local gRPC. So this is pretty cool. He also then, if you look down at the bottom, he's got link also to gRPC UI, and you'll see links to his other related posts. He's been digging deep into gRPC lately. So good
stuff.
So
it's gRP curl, not gRPC URL?
Yeah, it's gRP curl. Or gRPC URL. I don't know. Let's move on. So Indra is talking about Azure Active Directory on .NET Core 3.1. So some really cool stuff here, including, this is a large, people ask, does Microsoft use .NET, and, is Microsoft using .NET Core and stuff? So it's always really cool to see these things where they talk about at scale, how they're really, like making these, how they're using .NET Core and how they're making big migrations and stuff. So this is 115 billion requests a day. They talk about why moving to .NET Core. Some cool stuff up front, cutting CPU cost by 50%. So that is pretty darn cool. And then they talk, and I think this is really the best part of the thing here, is talking about like the decisions they made. So this is a migration made over time. Most migrations are not like, just a short cut over. Anything that's big and running at scale takes some time to do like a phase transition. So here they talk about some of the design decisions, and they're using IIS, meeting their requirements for TLS and some other stuff. But they talk about why they made those decisions. And then just as far as like migrating the applications and dependencies, and then they talk about also the gradual rollout. And again, I think that's really a key feature, of any migration, is to plan your migration so that you can do it over time. So this is, they did kind of a scaled and they move traffic from one to the other. And they talk about some of their learnings here, like for instance, ASP.NET Core being strict on RFCs. And just, some like kind of tales from the trenches stuff, like trailing white space, auto trim from path and stuff. So thought this was very cool.
I will say on the thing about RFCs are super not specific. They kind of say ABC, but they don't say not B sharp or whatever. So there are a lot of like undefined behaviors that servers kind of implement and have over the years that aren't embodied in the text of the spec. But
that's
have been codified
some of the world's simplest standards, like JSON, for example, which I know has caused a lot of ire, where the new JSON stack in .NET was quite strict philosophically about certain things like interpreting strings as numbers. But many now, I guess many years of people using other JSON implementations that were more lax on those things means that you have the standard and then you have like the de facto standard. And I think that's true of many RFCs. It's also just the internet in general, right? I mean, open standards are like this because in the early days of the internet, the rush to be compatible often was far more important than the rush to be accurate. And so we have legacy that's just going to live with us forever, and we need to find ways to balance that. This is an interesting example. Also, some of the examples here I like there's been a number of projects I'm aware of now where they move from ASP.NET to ASP.NET Core, even things like DasBlog, which Hanselman runs for his blog site, where there are behaviors of ASP.NET or IIS that are so quirky, where like you have no understanding that these things are taking place underneath you, but they do, and they have done for decades now. And then you move to ASP.NET Core running on Linux, and like all these weird requests that otherwise would have been sanitized, or things were padded, or slashes were changed, or things were encoded a different way, or whatever it was, are now hitting your server, or now being rejected by your server where they weren't before. And I've seen lots of examples of that over the last few years with as people migrate to Core, where they discover those things. And they're actually very difficult for us to just document. Like, we could attempt to just build like the huge reference of every possible quirk, but they're quirks. Like, even a lot of these things aren't documented as they are today. Their behavior isn't documented that way. It's just kind of how it works. And so being able to do like a catalog has been somewhat difficult. I know the Roslyn team went through this as well, obviously, and a slightly related thing where they moved from the old compiler to the new compiler, having to maintain all these behaviors that weren't necessarily documented, but they became documented as part of re-implementing everything, moving to Roslyn. So,
cool. Now, one thing you mentioned in there was about some of the effects of moving to like cross-platform and stuff, and that's actually one of the things I noticed in this. This is a .NET 5 networking improvements. There's a ton of stuff in here. There's a lot of sample code. There's a lot of information in here. I had a few things I wanted to call out. So this was actually one of them, the consistent cross-platform implementation. This is so tricky, and you guys know this because like the networking and a lot of these things are system services, and including like crypto and other sorts of things with that, right? So like getting consistent cross-platform requires some difficult choices. So that is one of the things. Another thing, so there's HTTP2, which is a big thing. Also towards the end, there's some interesting information about about telemetry. So there's information in here about telemetry, and we've had Sebastian's covered some of this stuff on some other community stand-ups, but there's a lot of great stuff going on with telemetry, and so that's kind of also
just to clarify, this use of the word telemetry is referring to your ability to monitor your own code, as opposed to the often, I think that's telemetry in the context of our world often leans towards the us listening to what you're doing.
It's a bad word.
Yeah. So in this case, it means, we instrumented the .NET network stack more so that you can get better messages about what's going on, rather than like we're now sending more information back to like mothership or something.
Yeah.
Yeah. So we added counters and events to HTTP outgoing requests, sockets, a bunch of things in the networking stack, so you can track end-to-end stuff from ASP.NET Core to HTTP client to sockets and figure out where the time is being spent.
Yeah, some really cool stuff. And this one doesn't dig into it, but all the stuff too with like I forget what it's called, open telemetry or whatever, but the telemetry that goes through, like, you can trace all the way through the stack. So from like inside a browser request, and you can trace it to multiple, like throughout the entire like microservice application.
Yeah, distributed tracing in general, right?
Exactly. Yeah. It's a lot of good stuff. This is just a survey we want you to take. Dan Roth pinged me about this last week, and I went through and I gave my feedback, and I encourage people to do that. It's a quick, easy, fun survey. It's stuff like you can rip through this in 5-10 minutes. Of course, pick dark mode. That's the one I'll give you that answer. But there's some things in here where it just says like, which of these do you prefer? So please, spend 5 minutes and go through this. The link is in the, I shared out the link to this, and I'll post it again at the end of the chat. So,
Damian, weren't you the PM that chose the colors?
Yeah, originally. So the story here is, if you scroll down to option B, although you chose dark mode, there was no dark mode when we did all this. One of the things we struggled with Razer right in the beginnings, 11 years ago, was there. If you look at line 5, we call that a Razer expression, where it says at current count. That expression doesn't have a delimiter at the end, right? It has an opening delimiter. That's a transition character, really more than a delimiter. And then there's no transition at the end. The parser has smarts to figure out when you've transitioned away from code, in this case, current count, which is a C# variable name, or identifier, I should say, and then back to HTML in this case, or plain text. Or in the context of Razer, it's either code or it's HTML. So in ASPX, you would have a trailing character in order to delimit that, or PHP or Mustache, or pretty much any other templating language on the planet. And we thought we were super clever, and so we built Razer to not have that trailing character, which means that the parser has a whole bunch of extra smarts in it to try and understand those transitions. So we decided that because of that sort of characteristic, it would be difficult in the editor to know necessarily where the C# expression ended and then where the HTML transition occurred. And this is obviously the simplest case, right? It's just an identifier, but there are other far more complicated cases where the parser would allow you to have white space and then still be in code. And so we decided to add this background highlighting, which you can see here over everything that is determined to be C# code. Okay. The yellow background is what's called a directive in Razer. So at page, at code, the curly brace. You can think of them kind of like pre-processing characters from a parsing point of view. They're everything that the parser kind of finds first to get the structure of the document in this case. So that's the yellow background. And then everything else is kind of HTML and colorized that way, or it's C# and colorized that way. But as you can see from line 9 to 16, that entire block is C#. So everything it has a background color and just looks weird. That wasn't idiomatic when we built Razer. Like, it wasn't usual to have large blocks like that very often when you were first doing like web pages. It was back then. Now it's a lot more common because of the programming models that we have using Razer, and so we're re-looking at this to figure out what the right way of displaying this is.
And I don't know if I should. I mean, some of the feedback I shared with Dan is I preferred option B. Because I do like to see what is C# and what is processed as HTML or JavaScript. But that block, the whole block of 9 through 16, I prefer that being just an entire block, like just color the whole line,
So I must admit, my idea here was that I'd prefer to have any Razer expression where there are blocks and there are expressions, right? Blocks have a delimiter. Anything, or have like an opening and closing, whether it's a parentheses for a delimited expression, or whether it's a curly brace for an actual code block. I think those should just not have the background color at all. And we should only have the background color for those sort of inline expressions. I'm not sure that's an option that's been exhibited in the survey, but I think that would be pretty cool.
That's basically what I said. I said either color 9 through 16, give it all, the entire block, make it all light or all dark, but just make it a block. One thing that's a little weird, line 7, that at on click. Shouldn't the on click
the new Blazor stuff, right?
Yeah.
So again, that's what they chose to do to show that attribute is a component attribute from Blazor's point of view. And they chose they went back and forwards on how to denote those while Blazor was moving to 1.0, and they made a big breaking change at one point from like preview 7 to 8 or something, where that at sign moved from being on the attribute from being on the value. And so I don't know, like, it's interesting because the at sign is a transition character in Razer. That's kind of semantically what it's supposed to mean. So I think this works well. Like, you're transitioning from a standard HTML element to, hey, this is a Blazor attribute, or a component attribute, I should say now. And so there's that transition. I think that works fine. The colorization is a little odd to me. I'm not quite sure whether that's the right, like the yellow background on the at there makes sense, but it is on the at everywhere else. So I don't know. Maybe that's fine.
Yeah, interesting. Well, anyhow, take the survey. Let us know. And there's plenty of spaces on these. Why do you prefer or whatever?
Yeah.
So I let
if
them
nothing
hang.
else, it shows you that we pain over these things.
Yeah.
And it's impossible to make everyone happy.
Yep. Cool. This was fun. This is from the Stack Overflow team, Dean, I believe, and he talked about iConfiguration and how they do it at Stack Overflow. I love that. Just in general, at Stack Overflow, they always share how they're using .NET Core and how it works for them. So he starts by describing, configuration in .NET. Talks about how they use all the different things, including they're like using Azure with Key Vault and stuff. He does talk about a few things. One that's interesting here is talking about substitution. So they have an extension package called, I blew it up and lost it. It's Stack Exchange Utils configuration. And it basically adds in this extension method for with substitution. And the reason they do that is to allow substituting in things like passwords or whatever. So they
to reference variables in the config from other config sources, I think.
Yeah, exactly.
Yeah.
So they do that, and then he also talks about namespacing as well, and that they have things in there for handling prefixes. So they'll do it with prefix and globals and secrets and stuff. So it's nice. So, I mean, it is neat for me. I feel like the configuration system handles, probably 90+% of cases, but it's also nice that it's configurable. And this is a really nice syntax to just be able to add in with substitution and have that pulled in. So pretty neat.
Nice.
I just have one Blazor post to share this week. I try and share them, save those for we have the monthly Blazor focus shows going on now, which is cool. And Safia hosts those. So, but this is a cool one. I always have to feature Andrew Locke's post. Here he does kind of a deep dive into pre-rendering with Blazor WebAssembly apps. And we've had some posts on pre-rendering before, but I always love Andrew's because he does a really good job of kind of explaining the problem, explaining, what's going on. And he has some great diagrams as well. So he talks about what you can do with pre-rendering and, not like pre-rendering on the server so that you don't have to, wait for the big pulling everything down and processing on the client before you show anything. So he talks about, how you can do that. He does a whole walkthrough setting that up, and he shows converting an application to use pre-rendering. The stuff I'm going to skip down towards the end because I want to make sure we have plenty of time for David. So some of the stuff he talks about is the trade-offs. And as he taught, so this is still his kind of walkthrough of how to set it up. Some of the stuff he talks about in the trade-offs here is, so it's great. You avoid the, loading flash and some of the stuff. You can depending how you do things, you can end up getting data fetched twice. You have to consider your dependencies. And another thing is it does make changes in your hosting because you're actually running a server-side application. So anyways, cool stuff. Okay, I've got just 3 quick ones here before.
I was just going to make a comment on that. Sorry, I couldn't find the mute button. I keep playing with my Windows, trying to get all the chat on one screen, and I'm just making an absolute meal of it. It reminds me, one of the things I've been meaning to do a short video or post on recently is about razer preflushing. It's a feature that we added as part of ASP.NET Core because it was very, very tricky to do in ASP.NET MVC previously. And it occurs to me that combining Blazor server pre-rendering with razer preflushing on the host page is probably something that people would want to do together for the reasons that you just talked about, including avoiding header line blocking and getting the style sheet links rendered into the client so they can be downloaded asynchronously, all that type of stuff. So I will endeavor, I promise, to put that together, because it isn't that tricky today to do so, but it does come with a bunch of side effects that you need to be aware of. And so it is worth like a 15 or 20 minute overview. And so if people are interested in that, let me know on Twitter or in the chat, and I'll work to put something together.
Yeah, cool. All right, let me see. Here's just 3 quick ones I wanted to share, and this is all 3 of these just came across my feed over the past few days, and I just wanted to I thought this was kind of cool context as we pass over to David. But it was the anniversary of jQuery. So back in 2006, January 14 was when it was kind of first announced or released. And, people, there's always a backlash of things over time, but jQuery, I feel like, added quite a bit and like transformed web development by giving you a consistent API that you could program against. And in a lot of ways, it was a huge polyfill. And over time, browsers like standardized, and just about everything in JavaScript is now kind of just native built in. Like you can just do query selector all or whatever. But it was a pretty amazing change at that time to allow you to do this kind of cross-platform front-end UI that actually worked.
We use jQuery in the Siglar client-side library. I mean, it's still there in the first version of Siglar, and people complain about it now because now it's like out of fashion. But back in the day, man, it saved us so much code.
Oh man, It's still used in our MVC client validation, by the way. Like the latest version, .NET 5, ASP.NET Core, still uses jQuery for client-side validation and jQuery Validate plugin. It is something that we are aware that we should probably fix. But it has yet to make its way up the priority list enough to do so. I mean, there's a lot of attention, obviously, on things like Blazor and stuff, and so most of the effort is going there, as opposed to investing a few months in building an alternate client-side validation story.
Yeah, cool. Yeah, and it's interesting, even like Bootstrap just recently, moved off of requiring JavaScript for stuff. I mean, it's pretty kind of universal.
The future.
Another thing, NuGet announcing 10-year birthday for NuGet, which also kind of, like all these things happened. NuGet having a consistent package manager for .NET, made a huge difference. And then one other funny one was I just saw, I have an extension for Twitter, and it pops up pulling back things from previous years. And this just cracked me up. This is something that I blogged in 2014, and it was a look back at 2013 and a look ahead to 2014. And some of the themes that just kind of cracked me up a bit. There was the one ASP.NET, which I feel like we actually kind of did get there. There's some interesting stuff about Visual Studio as an editor, and it's interesting to me, like, in some ways, Visual Studio did pick up some of this stuff, but then also there's a lot of Visual Studio code, and exactly. And so, looking at Web Essentials and here's one that definitely did happen, was the whole release and update speed. Back then it was maybe every year or so, and we really moved to kind of these point releases and every quarter and stuff. Externalization of ASP.NET. So looking at, moving things out of one big kind of monolithic thing. Here we're looking at Owen and Katana. And then, I did an overview of releases, and then I kind of wrapped up with some stuff you need to understand, and there's ASP.NET Identity. Identity is like, I don't know, it's moved a bit.
Amazing, incredible. What?
Yeah. Bootstrap
version 7.
Yep. There you go.
I think it just speaks to the complexity of identity as a concept in the technology world over the 20 years or more that I've been working in it. When we started, it was just Windows, right? All we really cared about was, you've got a Windows user, there you go. That's who it is. Let's all fire NTLM and we're off to the races. And then things got more distributed and heterogeneous and everything got hella complicated.
Yeah. And it's hard. I think the biggest thing I run into most of the time, like you learn identity or it's built into the templates and it generally works. The hardest thing I always run into when I talk to customers is migrating. So it's moving from version to version of identity gets more difficult. But like you said, it's just things move over time. So,
well, I think it's
storing password in a database is just, it just seems like a bad idea.
Seems like headache now. I think the other characteristic of identity with regards to our stack that makes it a little more impactful when it has to change is that it's the only thing that has a schema. It's the only thing that has a data store really in our stack. Like nothing else is stateful. Everything else just is a request pipeline and then goes away or lives in the process. Identity has a database. And so if we decide to add a feature that generally requires a schema change, which means you've now got a database migration. And sometimes, as we all know, schema changes are just flat out incompatible. Like you can't do them in one step. But as we're moving from one software version to another, you may have customized the schema, by the way, because identity is fully customizable. So it's just an incredibly difficult thing for us to make stable while also utilizing the features of the data store as long as we're staying with a relational store. Like we could choose to default to like a document store system instead, and then it would be a lot easier in theory, right? Because there's no schema you have to migrate as such. You still need to think about some things. But part of the issue with using relational schemas over time is that if you want to keep their sort of normalized form, you have to maintain referential integrity. You have to think about how constraints can be applied from one version to another. They typically can't. You need to do multi-phase deployment. We just don't have all of that built into our stack, really. Usually customers use their own techniques and own tools to migrate their schemas over time. And so, I mean, this is just a thought that occurred to me like right now. Like this is actually something that makes it quite difficult, I think, for identity to stay stable, along with the fact that the industry keeps coming up with new ways to authenticate users because, and security best practice changes from year to year because people find ways to exploit the web because of how open it is, and so it just changes a lot due to those things.
Yeah, cool. Well, that's all my links. The last one I'm including is David's link, and I'll pass over to you. But yeah, and then I'll share the links again in the chat. Thanks again to the wonderful community for all the cool stuff you guys do.
For doing our work for us.
Exactly. All right. So
it's their work. We do our work. And they do their work.
Yeah. We don't have to do any work at all. That's right. So you're saying. All right. So am I showing myself yet? Is it still on these two screens? I figured I'd go through the slides again. I saw some complaints last time about how crazy it was. Some people like crypto, some people don't like the craziness of jumping around. I think we'll do a mix this time to make everyone happier. So I'll just go through the anatomy of a request based on the slides that I had before. And we could talk about all the stages and then we could interject commentary on what happened at this part in the pipeline during it being built. If there are any questions you want to ask about anything, just ask, I guess on YouTube or via any of the channels being broadcast on, and then we'll answer it best we can. So typically, let me start over from where I think before last time I showed this slide, which was how ASP.NET Core is kind of this layered stack where you have the host, you have middleware, routing, MVC, signaler, frameworks, and then other frameworks. So as you can see, Web API and pages are built on top of MVC, and you have the rest of the stack all layered like this. And then I went through dependency injection, a couple of principles behind some of that stuff. If you missed it, take a look at what we did before. And then we'll go through now the anatomy of a single request, which kind of explains how the stack comes together, right, end to end. And John, if you have any questions or anything, just like jump in, and because I can see my screen, I can't see anything else right now, so it'll be hard for me to kind of flip between two things.
Sounds good.
I could use my phone, I guess, but whatever. So the server is the first thing that sees the incoming request. It could be from an underlying API like HTTP System Windows. It could be from IIS, or it could be parsing bytes from a socket, right? And its job is to take the incoming request from in any form and turn it into this thing called an feature collection. And that's kind of the main primitive that the ASP.NET Core expects to create from the incoming request, right? And we'll talk about what that is in a second. Here are some examples of the server interface in ASP.NET Core. Cacheable implements the iServer interface, HTTP sys, which is the kernel mode driver. So in Windows, I don't know what version it came into play, but in Windows, there is an HTTP implementation that is basically built for IIS, but it's actually in the kernel. And it's called http.sys. And we actually expose a server in ASP.NET Core, an implementation that P invokes into Windows to do HTTP. So we have Cacheable, HTTP sys, and then we have IIS, which is the server in Windows as well, built on top of HTTP sys. So there's layers here. There's test server. Test server is the in-memory server. There's no request or response really. Think of it as a server used for authoring tests as an end-to-end. So you can host test server in memory. It won't make any actual request. It will just send the request in memory to the server side. In the same process, it's very fast, so good for testing. And then you can build your own server. I think I've seen maybe 2 other servers. But it's a super advanced thing to do, so it's not like you would have a bunch of different servers. But you can imagine new features coming along, and someone wanted to try out a new experiment, right? So you could build your own iServer, plug into ASP.NET, and then still use the rest of the stack, the whole pipeline, and have the whole thing just work.
As an example, we did build an in-memory iServer that literally every request was a method invocation from inside the. And I say we built one. I did a ridiculous one for a demo once. But you could see how that could be useful in like a testing scenario, for example. And then we have a test host, I believe, that plugs in a custom iServer, right? I
did see somebody write a file-based iServer. So you would write a file on disk, put an HTTP request in a file. It was for fun to learn. You put a request in a file, and a thing would watch, the server implementation would watch the disk for new files and invoke your app whenever a new request came into the file. This is kind of fun.
I mean, you can imagine a whole bunch of things. Like if you think back to like MSMQ and other types of messaging, X509, or that's a cert thing. The other one, you could imagine people creating sort of gnarly or somewhat esoteric iServer implementations to make everything look like a web request, even though it was something else that was coming in.
Yep, exactly. So this is the iServer
question a second ago, which is just nerdy. Damian already kind of answered it, but I think it's just nerdy and fun. Is any plans on Rio transport? I know we talked about that kind of long ago.
So the fun thing about so there's transports and there's servers, and the server encapsulates the transport as well. At least in the case of Kestrel, if you wanted to do a Rio transport, you could do it as a whole iServer, but you have to re-implement HTTP 1, HTTP 2, HTTP 3, etc. You can actually plug into Kestrel at a different layer that's even lower than iServer, and we'll get to it in the deck. But as for us doing a Rio transport, I don't think that has been the plan since, like, I don't know.
I mean, as I answered, there's a couple of prototype ones floating around. I know Ben wrote one. I think Lou wrote one. And I think those are the 2. There may have been another one we saw at one point.
There's one more.
Yeah. The challenge with Rio is because, as I understand it, is because of its sort of upfront registered memory sort of model. You have to like allocate a whole block of sort of space for the Rio mechanics to kind of exist, and then so it kind of suggests that you want to know how many connections you're going to have, and then how many requests they're going to perform, and how big those requests will be, so that you can allocate that memory to the right size up front. Dynamically reallocating that stuff is possible, I believe, but you can't like do it in the context of a connection, if I recall. Like you would have to like drop that connection and move it to a different pool or something if you wanted it, if it suddenly started to do bigger memory, like bigger requests or something. I don't know. Like it seemed like at the time it was like, it's more designed for the scenarios where you have a server doing a very specific thing, which is very kind of known ahead of time, and you want it to be incredibly memory efficient or stable with its memory use, and get incredibly high throughput that way. But it didn't seem like it was a good fit for a more general server.
Right. Yep. Yeah. You would need to allocate a ton of memory per connection up front.
Just for context, this is RIO stands for registered IO.
Yep, that's right.
It's a
an
Windows
extension to
feature.
WinSock in Windows. On Windows 8 and above or something like that, I think.
I think it was 7 actually, but
7 and above. Yeah,
might have been that actually.
Windows Server 2012 is the doc I'm looking at.
That's 8.
That's 8. Yeah, you're right.
Cool.
Yeah. And we did play with it. It is a little bit expensive. The memory required per connection was, I think, something like, I think our test was like 8K. And I think unlike using the raw socket APIs in Windows, if you didn't have a pending receive with the actual buffer ready, there was the OS wasn't there to do it for you. So if you didn't do it, like if you didn't have the memory ready, it would resend the packet or something, or you drop packets that have to be resent to you from the client side. So I think that there were a bunch of gotchas like that we didn't really understand at first when we were looking at RIO. All right. So the iServer interface. In ASP.NET Core, you'll see this feature collection appear a bunch of times. And we'll talk about it later on, but for now, you could think of it as a dynamic bag of properties. All right. The intent was that we wanted to be able to represent an object that could add and remove interfaces dynamically, and that isn't possible in .NET. So this type was basically a shim to enable those kinds of things. You want the consumer to be able to detect if the server implements this feature without having to actually implement a concrete interface on a type, because you can remove and add features dynamically based on whatever, right? Arbitrary code. Start async is pretty simple. You pass in what is called the application. The application is prepared by whoever is hosting the server. By default in ASP.NET Core, the hosting layer, the core hosting layer, but when you call webhost use startup, that is the code that's responsible for taking your middleware pipeline and turning it into an application. Stop is simple. Stop takes in a token and it will stop the server from running. And the application itself has 3 main functions, and everything here is generic, and I'll explain why that is in a second. Create context, so the server passes in the feature collection to the application, and the application, the server calls create context, passing in its feature collection, and you get a context back. That's T context. There's dispose context for after the request is over, and you pass back in the context and the exception if there was any. And then there's process request async, right? One strange thing is that T context actually isn't typed as the HTTP context. This was one thing we wanted to carry forward from the ideas that Owen originally designed back in however long that was ago. Owen is the open web interface for .NET, and there's a long history about it. If you're interested, go search for OWIN on your favorite search engine, and you'll find some information. But the intent here was to decouple the server implementations from HTTP context. Before we had finished ASP.NET Core, we thought HTTP context may end up being as bloated as the one on System Web. System Web, if you ever looked, the HTTP context kind of has the kitchen sink on it. Mm-hmm. Everything on the planet that was ever there in HTTP seems to have been put on the HTTP context, and we want to avoid our servers from being coupled from that specific implementation. So the generic here, the T context, can be any server. So there's this small decoupling between the server implementation and HTTP context, where the host can provide any application as long as it can convert from a feature collection, a bag of features for the HTTP request, to this T context, right? And the server itself, the caller itself owns T context, if that makes sense.
Do you think it's surprising that we haven't seen a more action in the community with regards to like building micro contexts? Like you could run Kestrel as it is, which only provides a feature collection, and then the HTTP context is part of the ASP.NET Core like app model side of the world. Mm-hmm. But you could certainly imagine a world where there is a smaller HTTP context, like a micro context that still runs on Kestrel, but just exposes very little to make it more of a pure HTTP server. Because there's things today, even on HTTP context, that you and I actually voted against, but lost.
Yeah.
And probably a few other things that you could decide, oh, I don't want that there. Even things like form collection and a whole bunch of other stuff.
Yep.
Like you may not want that because they're very, maybe browser centric or paradigms to do with a human sitting at the keyboard rather than a machine talking to your server. I am a little surprised that there hasn't been more exploration into this, I guess, given the size of our community.
I don't know how well known this stuff is.
That's fair.
I don't think we even have it docked to this level of detail.
It is, or
it isn't though.
I think it's like docked at an API spec level, but not a hey, if you want to do this thing, level? Here's your
there's no content on this.
For example, would it make sense to, like you're saying, have a narrowly scoped context? Would that do we do that for like an API? Like if I do an API app?
No, because the issue with that is that you lose middleware, right? So middleware is typed against the HTTP context, so you would lose all those features.
Right. Did one of your diagrams show those layers? Like HTTP context up is our app model, is the ASP.NET Core app model. And that includes the concept of a middleware pipeline, right? Yep. And MVC is another app model that builds on top of that app model. And I think Fowler talked about, like, we built a stack for building other stacks. Like MVC is a stack on top of a stack that a server plugs into. And we're talking about just the server here. So the one unfortunate thing is that HTTP context means middleware. Otherwise, you end up with a stack that looks like pure Owen, which didn't have a type, you didn't have a context. Like, because you need a shape, you need a type in the .NET world to hang your middleware pipeline off. The original Owen, the pure Owen, doesn't have a type. It's just like a bunch of func delegates.
Dictionaries, right?
So, and dictionaries, right? Because they're in the system assembly. And so to build middleware pipeline, you have to like chain these funks of things together, and they live in a dictionary. It's not usable, is the point. And so maybe there's a middle ground, but we had to draw the line somewhere, and that's where we decided to draw it. And it's kind of stuck there forever now, until we do, maybe 10 years, 20 years from now, another stack appears. But
there's no, you either use the whole HTTP context, in which case you bring in which you need for middleware, or you don't. So it seems like that's because as you're describing, like it's a stack for building, or it's a toolkit for building stacks and stuff. That seems like the most obvious. Like, as I'm thinking back at, hey, like the Azure AD team did this really cool, we looked at how they optimized. That seems like that's the sort of thing where if somebody is going to be doing the sort of stuff you're talking about, Damian, you know what I mean? Where they're going to like get some benefit out of really optimizing. That seems like
there's two ways I could see that happening. One is, if I recall correctly, that the hosting mechanics has a mechanism for actually converting one context to another. Like, you can say, I can take this T context and turn it into this T context. Is that right, Fowler? So you can do
that was in Katana.
What's that? That was Katana?
I believe that was in Katana.
We don't have that in Core?
No.
That's unfortunate. So then your only option is to plug in lower than when the T context exists. And I don't think we have composition primitives for that. I maybe that I mean, I'm just using big words. I don't think we have like a first class way of saying, I'm going to add this piece of code that I want to handle requests that match this thing, and I want that to go through this pipeline. But this piece of code uses the HTTP context pipeline, because all of our pipeline primitives exist. They hang off HTTP context. They live in the middleware pipeline, like routing and map and all those type of things. They live too high in the stack. There is a composition layer underneath that, which is the connection sort of composition. What do we call it? I'm blanking. The
middleware pipeline, but for
the handlers, right? Like the connection handlers and the transport stuff. Like, but that's not really designed to be for a start, it's not a per request dispatching composition kind of primitive. It's more of a connection handling one, if I recall.
So
two things. Can you hit the hide button down at the bottom where it says stream error sharing? And then also zoom the code way in. We got people that watch on their phones and stuff. So it's
on their phone. That's awesome.
We do. It's crazy. We see on the like YouTube stats and stuff, people watch this on phones and their watches, I'm sure, and who knows what else.
I'm going to create a casual server without ASP.NET Core just to show that it's possible.
While you're doing that,
And
there's discussion, people are saying, wow, this is complicated and stuff. And it's like, what we're doing intentionally here is digging into, when you do file new project, a lot of this stuff is abstracted with the, like, you start up.
it's hidden.
Stuff, right? Yeah.
Yep.
So
exactly.
You never have to deal with this, but this is good to know, like, how it's all built and what's actually going on.
I mean, it's like most people don't read IL, and then even fewer people read assembly, right? And no one's looking at the registers live. Like, I mean, very few people. But ASP.NET Core has its own stuff that 99.9% of people will never look at, but is designed that way to give us flexibility, because we learned from the previous effort that it comes back and it bites you. Like, HTTP context in the old stack was intrinsically tied to IIS, even though it was architecturally designed internally to not be. Over time, because of the nature of Windows and the nature of how HTTP sys evolved and added support for HTTP features that we wanted, like WebSockets and various other things, it all became one, effectively a ball of mud. Like, HTTP request was intrinsically backed by IIS-7 worker request and all these things that's the only place the features. They were not implemented in an abstract way. They ultimately all ended up.
First they were, and then it slowly just got
and it was at first. It took like 7 versions of IIS before it really hit the fan, so to say. And then it was just like, yeah, this is all, you don't get that feature unless you're running an IIS-7, which, fair enough. Most people were only running ASP.NET on IIS. But we really tried to make sure that wasn't the case with ASP.NET Core.
Just to share while you're doing this, we do have a few people since I said that, we had a few people pop in and say, yep, on mobile. So, yep.
Nice.
All right.
Okay, so here's a super complicated, don't try this at home, newing up like Kestrel's guts without ASP.NET Core, right? So this is creating Kestrel. This is the options, kind of ugly. And we haven't spent any time to make this nice. That's why it's so ugly.
Yeah, it could be one method, right? Someone could build a factory class.
Could be
my
create server, right? Yeah, exactly. So the thing you have to give it is an application. The application implements the interface we spoke about. Kestrel will call create contacts, dispose contacts, and process requests async. And the feature collection that I mentioned here, this type is actually implemented in Kestrel on one of its internal types. So the thing that I'm doing here, I'm just round tripping whatever Kestrel gave me to use for requests, right? I could use HTTP context here if I wanted to, because that actually works. That's why it's a bit simpler. This isn't crazy. But this should actually run. Let's actually try to make it work. So create context, I'll create a new default HTTP context because we have this. And guess what it takes? A feature collection. It was made for this. Dispose, I'll ignore. Respond, start, right, async. Right. So let's try this. Run this. Hope it's not running IIS because that would break. I think I made it run the app. What do you want? Oh, I know what this is. Oh no.
Bail?
No, bail. Never. I said it was ugly. Just don't look.
Did we mention that we haven't spent any time trying to make this nice?
Don't do it ever.
Yet again, like I said before, perfect opportunity for someone to come and make, my raw Kestrel server package, which has an API that they shape to make all this lovely. And it's not really ASP.NET Core at that point. It's just using Kestrel and whatever API you come up with.
I think really it would be useful to, like, I don't know if it's a blog post or a gist or whatever, but it's like, here's some opportunities. You know what I mean?
Yeah. They're not in one place. We've done things like this over the years. I know Fowler's published a bunch of different gists over the years on Twitter and things, but they're definitely not in one place.
And they aren't coherent.
You mean like an ASP.NET Core nerd snipe page? That's what you mean.
Yeah, exactly. Yeah.
That's a good idea. Maybe we should just have a repo, Fowler, of like nerd snipe ideas for ASP.NET Core.
One repo?
just a repo of like random ideas, like Alarms
Yeah.
or $1 million ideas OneNote.
Yeah.
And it's just like 8-minute core nerd sniping, and you just like people can go in there and get motivated to try and make a thing, and it's just enough in each one to set you on the right path.
Yep.
Yeah.
So here's an extensibility point we've created, and here's some ways that people.
Here's an idea. Wouldn't it be cool if?
Yep.
Yeah. All right. So it should be working now. So I did a bunch of stuff here, made a server, called start with my application. So Kestrel, you should see it calling create context, process request async, and then dispose context. So it's gonna run like magic, blah, 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 blah. In a super small window for some reason. And you can see create context being called from Kestrel, HTTP2, obviously, because it's in the browser. Process request async, and this is what typically calls the pipeline that was built up from your startup class. And then dispose context when it's finished, with no exception because there was none.
Okay.
All right, for that we made this work in, I don't know how long that was.
Bob asks an interesting question that I was going to answer in chat, but we should just do it in person, I think. He says, is it possible to debableize the levels to get back to the raw request? And I think if you're in middleware, for example, I think it's an interesting question, because the reality is, from my understanding, is that it really depends on what you mean by the raw request. By the time that you get it in middleware, so much has already occurred. And because of the nature of HTTP, it's really a forward-only protocol when it comes to the request in most cases. Like, you can't really get back to let me go back and read the headers again, because we already read them. The network stream has moved on. You can get to the underlying streams, absolutely, and we can get them as either a stream, like a .NET stream, or a .NET pipe.
For the body, not for the headers and a start line.
The headers already happened, and so you can get that body on the way in, and you can obviously get it for the response on the way out for the body response, not for the header. And that's because our app model has primitives wrapped around header processing, which include security features. They include buffering and memory reuse. They include nice types that sit on top of what would ultimately gets passed down through the headers. Cookies is just a header at the end of the day, but who wants to work with a raw string for cookies? Because it's all this, it's a DSL effectively. It's a different encoding where you've got like timeouts and all types of other stuff inside there. And there's lots of things like that in HTTP. But so you can't really do it from middleware when it comes to things that aren't the body, I guess is the short way to answer that. But you can get to the raw request as long as you're not in the middleware pipeline yet, and you write the code that lives in kind of the raw request handling part of the stack. Now, but I don't really think there's a way for us to do that while there's also ASP.NET Core sitting on top, right? We don't really have that construct, do we?
I will say one thing. So the HTTP context and request and response have these higher level things like host string, path string that do other encoding on top of the raw incoming request. The underlying features in the feature collection are a bit more raw. So the HTTP context does do more parsing lazily as you access these properties and fields. So for example, if you don't access cookies, it will never parse the cookies header and like turn it into this collection, right? Oh. So if you want to access the underlying data source for cookies, you could look in the header collection and get the raw cookie header without having to go through this thing, right? And same for query, same for most of the things on the request, but you can't get the bytes. Like the bytes are gone, right? So you can get the bytes. Sorry, you can get the information that we parse in the way we expose to you in the features. Right. But you can't go any further than that.
Right. And Ben calls out in the YouTube chat here that there are examples of what it looks like to build a raw HTTP server on Kestrel in our Tech and Power platform benchmarks, which don't use the middleware pipeline. They literally construct a mini framework, I guess is the way, like a micro framework, which plugs into Kestrel's dispatching primitives, which literally ask you to parse the bytes. Well, that's not even true. Kestrel does a bit of the parsing for you. And then Kestrel says, here's the beginning of a header. And here's like the offset effectively, or here's the span or whatever. Here's the bit of memory that contains this header value and even this header name. Like, do what you want with it. And then once this method is returned, I'll assume that you have either consumed that memory or you have not. Because ultimately, the thing you have to remember is there is data coming in off a network construct of some sort. Usually, you've got a network card and there's a network stack in the OS. There's memory allocated somewhere on your behalf. Somewhere, right? The Kestrel's doing that in this case. And then it is calling you back saying, I know enough about HTTP to know that this part of the memory stream that has currently come in, that is a request. A request is just a construct. Like, it's made up, right? It's just bytes over some thing that standard. It's all lies. So I know enough about HTTP to give you this handle, this chance right now to call a thing. But if you're using ASP.NET Core with middleware, you can't mix those two things together, as I understand it, on the same Kestrel instance. Is that right, Fowler, or can you do that?
That's right.
Yeah, okay. So you need to choose one or the other. You can build an app that runs raw on Kestrel. That is doable. We don't really document it other than the samples in the benchmarks, but you can do that. But you don't get anything of what the vast majority of people consider as ASP.NET Core. You just get Kestrel.
Yeah, I'm interested.
Again, opportunity for the community. If anyone wants to build like a crazy stack, which is literally on every request, you get a callback to say, we're at the point in the request where bytes have to be read for the headers, then you could do that. Someone asked, why can't you opt in per request to like read the headers or not? We talked about all that type of stuff when we were doing all this benchmarking about whether the header collection should even be parsed or populated on the HTTP context. Has to be parsed. And there were reasons like why one way or the other. A lot of it comes down to it makes memory management difficult. It makes certain APIs break. So if you don't opt into it and you call an API, it'll like explode or do something that you wouldn't expect because like the memory is not where you expect it to be. Some things can't be done lazily once another thing has already occurred. For example, a request is basically linear. And so I think where we landed, which is you kind of have to choose one mode or the other, is kind of makes sense. But as Fowler said, those higher level APIs on HTTP context are lazy. Like cookies doesn't really matter. We're going to read the value for cookies anyway into a block of memory, the raw value, but we're not going to parse that into a cookie collection until you ask us to. And we can do that at any point. We could do it multiple times. It doesn't matter, right? You could get the raw cookie header value and parse it using your own code into your own cookie collection type if you wanted to, because we already paid the cost of parsing it as a header and then putting it in a memory block for you somewhere so that you could read it as a what do we call it? Like a header string or header value or whatever we made that type.
String values,
String value, yeah.
Yep.
So one question here, this is just kind of interesting. So is it possible to run .NET Core other than Kestrel? So you're talking about kind of the whole kind of hosting layer. Where would that plug in if you weren't going to use Kestrel?
At all?
Yeah, like
to use as in they don't want to use ASP.NET Core at all, or you want to use something that was custom.
Yeah, I guess if you wanted to use a different server, where is that kind of plugged in?
So it depends. So ASP.NET Core is kind of this like super pluggable beast.
Mm-hmm.
So you could, for example, I erase create a builder, but let's see. I did what's it called now? Host.create. That one. The generic host creation pieces is configure web host. So this is what you use if you want to use ASP.NET Core. And if you use ASP.NET Core, you don't have to use Kestrel, but using ASP.NET Core anyway. So for example, when you get to the web host builder, you can use startup, use startup. Come on, extension method. There you go. Then I could say something like use Kestrel. I could have my own use server implementation here where I pass in the iServer that I implemented myself. Or you can use IIS integration, use HTTP sys, et cetera. So if you want to use ASP.NET Core and change the server, you could do this.
Awesome.
This is so cool. So look at this warning. It's only on Windows. Anyway.
Oh, was that the new OS stuff that we added in? Nice.
Yep. So what you do is you just suppress everything, obviously. So you could change the server. If you didn't want to use ASP.NET Core at all, You could implement your own hosted service that just ran whatever server you want to run. There's HTTP listener, which is deprecated in .NET Core. Deprecated, but legacy, I guess. Spin this up here and do your own listening, et cetera, et cetera. But yeah.
Cool.
Bob asks, can you insert a middleware at a specified level? Are those levels predefined?
No, there's no level, but someone actually had a really cool proposal for something, and I think they wrote, they actually wrote a component that did this.
You can insert
you can insert what headers? Yeah.
Well, then you can insert a middleware from something that isn't the application configure method, like using the startup filter and whatnot, and that will effectively just put it at the beginning, but you're still held to what any other filter is doing. So there is still an implied order there that you can't just say, I want to be first. You can't index a middleware into a known location, I guess is the short answer.
No, you can't. So this, we had someone actually design something like this because they had it at their company.
Interesting.
Where you could use name middleware and you can pass in names and you could predefine some names.
Oh, it would sort them for you?
Yeah.
That's a little bit like the stage
markers and
stage mark.
So you could look at this issue 27864. Let's see if that's interesting to you. But it's not in the box, no. Okay, so we got to one slide so far. Thanks.
I know.
Great questions.
We should just do more of these.
We totally should, yeah.
Yep. So we spoke about a bunch of this stuff, so I don't have to go into deep details. We even had an example. The feature collection is the thing that's special. It's what all servers are exposed to the next layer in the stack. The application is the thing that actually will manage the lifetime and creation of the T context that isn't the HTTP context, but is in most cases. Here's the feature collection interface. It's basically a dictionary from type to instance. And this is how we basically let you set lets you add an interface and get lets you get the current implementation of that interface. So you could think of it like a dynamic object, but a bit more efficient. And the way we get efficiency in ASP.NET Core is we kind of back these objects under the covers in the implementations with fields. So even though you're doing a lookup for, say, I don't know, some feature called iRequest feature, that's actually a field reference that we say, if the type is this type, then return this, right? And you only get into dictionary semantics for unknown features. So it may look inefficient from this interface, but it's flexible and fast in the default cases. And then you can also add more things that we didn't intend in the first place to be in there by adding more features. And here's an example of a feature. So when you ask for the raw underlying request, this is as raw as you can get. You can get strings, right? So we don't actually store bytes because the bytes get reused into a buffer pool. But we do turn the request line and headers into a bunch of strings. So for any request, the baseline set of features are scheme, protocol, method, path, base, path, query string, raw target, and the headers. And the header collection is a dictionary from string to string values, which is a custom struct that stores either one or an array of strings. We had a lot of discussions about what would happen to these interfaces if we ever want to use UTF-8 string. And I think the current thought is everything would break everywhere if we did UTF-8 strings. We don't have a good way to slide into to put it into our design without breaking public API. Because the issue with the strings are you kind of have to store the UTF-8 string or store either the UTF-8 string as bytes and the string, because most APIs still take strings. So during that phase where people are trying to move over to UTF-8 string, you'd have to have both, and it'd make performance worse. Right. So
otherwise, you'd have to do it like dynamically when people ask for it, and that would
on the fly,
like some implied conversion. But oh my gosh, like doing that in a memory efficient way,
it would break a lot of things. Yeah,
it would be horrible.
Is this related to, there was a thing about runes and stuff a while ago?
Oh, that's another thing altogether. Runes is a type now, right?
Right.
Yeah,
but it's designed around, runes is not designed around performance at all. In fact, it's kind of the opposite. Runes is designed around being to the letter correct with regard to to representing and
UTF-8
manipulating
and characters and
Yeah,
how you
characters.
integrate the characters
Right.
properly.
Which the web is just not really, like, as a concept, HTTP just isn't really an example of something that tries to do that. Like, you may have little islands of bytes inside your response that are definitely that you could choose to manipulate and build with the Rune class types that are because you want to get like super duper accuracy and whatnot. But yeah, text is a lot more complicated than than it has any right.
Surrogate pairs, man.
Yeah.
Here's an example of getting a raw feature from the HTTP context. The context is the HTTP context. Features is a feature collection. You call get feature. You can get the underlying feature. All the properties on the HTTP context, so like the path, etc., are backed by these features. So if you get the raw feature and muck with it, it'll recalculate the right value when you ask for it again on the HTTP context. So it's always kept in sync that way. So you can't really, I shouldn't say can't. You aren't supposed to be able to get out of sync with the feature and the actual data in the context because it has to check for the version, right?
There's a good question from user MS. I think we should take, John. Can you highlight it? I didn't log in, so
got it. Yep. Yeah. So this is the one here?
Yeah, I think the answer, as I understand it, and Fowler will tell me if I'm wrong, is because it's just code. Because it's just a method, basically. It's a method chain. And so changing it would mean reconstructing a dynamic
the whole thing
invocation thing. It's not like a loop in the sense
What's
that
the question?
We're looking up a thing and then calling 0, then 7, then 5, and then you could change it. It's just literally nested calls. Like it's a Russian doll model, right?
So the question is, why are the running order of middleware have to be coded and not configurable so you could change it at runtime without
changing code? They're asking why couldn't we design it so that the middleware order could be changed at runtime through config, for example?
Well, we could. We just don't want that because like inefficiencies and pluggability and like I think one thing that we moved away from in ASP.NET were dynamic systems. I think we want dynamism to be kind of added on by people who need it. We want the default situation to be pretty static for the most part. Yeah, exactly. So we don't want to design things that kind of tie the hands of everyone who may not need those features.
Yeah. Could you have like some sort of delegating middleware that like
does that? You can. Yeah.
You could
the guy built like a whole system for like name middleware and paths, and you could build that whole thing yourself. I think there are a couple of things that tie your hands with respect to dynamic middleware. The fact that you can't add services on the fly. So if you add or remove middleware on the fly, like at runtime, based on plugins being added and removed at runtime, you can't add services because the container is baked at runtime. So you need to have a different container for that component that isn't,
which is doable, but it's
exactly.
But like, imagine it is technically possible. You could build like a site that has an admin screen which visualizes the middleware pipeline, and then you could drag and drop the bits around. And then on the left-hand side, like different browser, you could hit F5 and see that it's running in a different order. It'll break sometimes. But you would basically be taking over. In the root pipeline, you would just have one middleware, which is your ordered dynamic middleware thing. And then inside that would be the logic where you're determining what to run first, second, third, and fourth based on some other config. That is doable.
Yep. Okay. Yeah, but I do think we are allergic as a team, or we were in the beginning, to features that felt like it would hamper the performance of everything in the entire stack just because we needed this one scenario to be dynamic. So it's the same reason we don't scan assemblies by default at startup anymore. Like that was a big thing that was in our heads when we did ASP.NET Core. We didn't want all those costs because of a scenario that you may never have to do in the box on by default.
Right.
All right, we probably need to wrap in the next 5, maybe 10.
Super done?
But we need to start wrapping up. Actually, maybe 10 minutes or so. Okay,
that sounds good. So I could keep going through the servers. Casual is interesting, at least. So Casual is our cross-platform web server. It's all in C#. It's optimized, very, 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 very optimized. And every single release we spend like, I don't know, how much time, Damian? Like, I don't know. Maybe at least one whole engineer trying to optimize it more.
Probably, yeah, because
Yep.
I mean, because when you say it's super optimized, it's architected in a way that we hopefully architected it in a way that means that we won't hit a limit where we can't optimize something we want to in the future, but we haven't got the full, every code path isn't perfectly optimized for every scenario, because that doesn't exist. That's a false thing. You can't do that. Like, you have to optimize for specific scenarios and make trade-offs. And so every release, we tend to, what we've done so far is, rather than revisit things, we kind of go, well, we haven't optimized this yet. Let's go off and focus on that. And that uncovers all the things that we want to optimize. And sometimes we hit things and go, oh, well, for this scenario, in order to optimize that, we may have to slightly impact that, because there are trade-offs. But luckily, so far, 5 versions in, we haven't had anything super bad like that. But that, I do expect that to happen more over time.
It's designed super well, so we're fine.
Yeah, Fowler's like, it's perfect. There is nothing that we will not be able to optimize. Except maybe a global thread pool does limit us a little bit, but even that is.
I want to bring that up, actually. So I think one area that we are going to end up spending more time on, because it basically is the thing that is at the center of all the server's performance, is the thread pool dispatch and blocking APIs, and how we schedule things on cores and CPUs. Will be a big focus, and it will be across team focus, not just for Kestrel, but in general. When you have these server applications, scheduling affects them so much, and it's really hard to predict the latency in some systems. And we also have work to do when you have NUMA machines,
multiple NUMA nodes. Or even, and maybe not even NUMA, but just like the concept of
lots of cores,
locality, and the scheduler or the scheduler knowing or making a smarter decision. Like, with the advent of ARM, obviously these days becoming more and more prolific, and more vendors having server uses for ARM, which I think is going to be interesting, which has a slightly different memory model, and chip architectures. Intel was kind of the dominating factor for a lot of time, and then AMD obviously is in the park now, and they took this chiplet design, which has a configurable memory model, so that you can choose effectively how many NUMA nodes you want on a certain die, because of how they architected it. But again, they're making changes to that in the next generation again. And then you've got things like really big iron, as we would call it, like multi-socket servers, where the interconnect between CPU 1 and CPU 2 can't be as fast as the interconnect between like cache level 1 on CPU 1 to cache level 2. Or to the main memory bank. And the scheduler doesn't necessarily know all that stuff today. And even if it does, it's scheduling for all users, like everybody. Like, it doesn't care. It doesn't know that the thing you've asked it to do is a network operation, which needs to get memory, which is closer to CPU. Like, it has no knowledge of any of that. And so that is limiting. And so you'll notice in other stacks, they may scale linearly as CPU core count goes up, irrespective of the CPU architecture, better, because they can just say, well, this thread lives on this CPU, and all requests and all connections associated with that, we're just going to pin to one place. And then there's all these other driver things, like there's networking stuff and virtualization and all this crap that I don't even understand. But all that can affect stuff when you get to a really high scale. And the last thing you want to do is make a scheduling decision like, I'm going to make this bit of code run over there because that's the one that's free right now, not realizing that that's going to literally be 1,000 times slower than if I had just waited a nanosecond and run it behind the thing that was on me right now.
Right. So that's one area I think we'll spend a lot more time on in the future, because I think we hit all the low-hanging fruit already. The low-hanging fruit has been, I think, optimized to death, even though we'll keep doing those things as well. But I think scheduling, we don't quite understand all the scenarios in which we should be doing what we're doing right now, and how we can improve it. The thread pool moving to managed code is a huge win, I think, in this case, because it's easy to experiment and try different things that we haven't in the past. Is that like 5 minutes left? So Kestrel has this this internal design where it has recall ASP.NET Core has a stack of things in the pipeline that run. We have that same level of abstraction, but underneath ASP.NET Core as well within Kestrel. In the very beginning, Kestrel was just an HTTP server hard coded to serve HTTP 1 and 2 and now 3. But I think as we got further along in the releases, we noticed that we actually had a general purpose stack to build arbitrary networking applications on Kestrel. So we made a change, I think it was in 2.0 or 2.1, where we kind of exposed Kestrel's guts to anyone to build things. And people have built some really, really interesting things that we didn't originally intend that they would build or design. So there's a transport like sockets or name pipes or whatever transport you want to use. It could be anything that is stream-based. Connection middleware can run over the low-level transport. So think of it like, HTTPS or TLS. I can run code that reads the bytes and looks for bad actors, reject connections based on IP address, etc. And then for HTTP specifically, we have a middleware that transforms the incoming raw connection into an HTTP connection because it understands the handshake. And then we have an HTTP protocol which actually implements the IP collection interface that all HTTP 1, 2, and 3 all implement in some form. So we kind of have this nice cascading thing that starts out as a transport low-level connection, goes to HTTP, and then all ties into one layer for all 3 HTTP versions. And that took a ton of refactoring because I recall when we added HTTP 2, the first go at HTTP 2, we duplicated like all the code. And then we had a couple of design reviews where we went, man, this is going to be super hard to maintain if we have like the code split. We were at first convinced that we had to do it that way because they were so different. But then after a couple more tries, we kind of figured out a way to abstract the common behavior of invoking the middleware pipeline and doing that stuff. I'm trying to isolate the other code. So we actually have a unified pipeline between 1, 2, and 3. That's super clean.
So it kind of came through in passing, but this is I want to call this out from the chat. So somebody was saying like, hey, what was that? So this is .NET 6 thread pool moving to C#.
Yeah.
Yeah. Anything else you want to say there? I don't know if we.
Oh yeah. So the thread pool historically, a long time ago, has been split between C# and C++. It was also available on the hosting. If you were going to host .NET in .NET Framework, you could actually use the thread pool from the native code side. So a bunch of that stuff has been, I think, removed because it wasn't exposed in .NET Core. And then we had an intern actually 2 or 3 years ago now port the thread pool from C++ to C# for Core RT, which is the native AOT project. And then here we are 3 years later, pulling that code back in from Core RT back into Core CLR, and which is now on by default in .NET 6. So we now have the thread pool fully moved to manage code, at least the worker thread pool. There's also the IO thread pool that we're trying to figure out if we can do both in .NET 6. The issue with the thread pool is so general purpose. It basically schedules everything in .NET. So there's this immediate fear that if you improve things in one scenario, you'll break some other scenario because we don't have good tests for all the possible ways you can use a thread pool. So for example, a thing that may improve ASP.NET Core may make Parallel 4 worse. So there's going to be a lot of tuning and also different hardware configurations, different machine sizes, different cores, different things can affect the performance. So there's a lot of apprehension when we see results from a perf run and we change the thread pool behavior, things may regress on some other machine. We made a change in .NET 6 to reduce the number of spin weights, I think, in concurrent queue, which is what the thread pool uses for its queue. And it was amazing on one machine and it was horrible on ARM. So we had to take the fix out. So I think we'll hit a bunch of those cases, but now that we're all in .NET, it's a bit easy to optimize and we'll have more eyes on it. And I think it's good for everyone.
Yeah, it's discussion in chat. People are wondering if performance and GC and all that kind of stuff. Obviously, that's all part of the development cycle and stuff.
Oh yeah. So. Yep. Cool. Are we over?
Yeah.
Super overtime. I'll stop here.
You know what? This is amazing. I think what's kind of neat about this is that there's there's a lot of great content here, but there's also a lot of like just discussions that we can kind of go deeper on and questions that people have. I'm almost feeling like we should, for a while, just like come back in a month and maybe do like a monthly architecture series, because
I was thinking the exact same thing.
I like that.
Cool. All right. So
Awesome.
we'll catch you back in a month. And if you have questions, ask us on Twitter. You can always reach any of us, or tweet over to @ASP.NET. This is amazing. So I've the slide deck is in the show notes, and I've also added the link to or in the community link notes, and the slide deck, or excuse me, part 1 is also there too. So for people that missed that. So that was incredible. Mind blown. Thanks so much, David. So, all right. So I'll reach out to you guys to schedule the next one. Maybe if we can just catch up in a month. And thanks everyone for watching.
Sounds good.
Cool.
All right. Bye.
See ya.